actually open for both of the side, and that's actually not appropriate. In fact, that was actually one of the questions that I can remember. And otherwise, there was problem in the present ham. Um, you have took your first initial decision parameter for the first point, but that should be for the second point, as you have seen in the midpoint circle drawing when we are doing that. This is the two things that I can remember that I need to have a concern about. The first question, that many students actually just simply taken some of the definition from the internet that they have written, or maybe sometimes from the slide about the virtual environment or virtual reality. But the question says that you actually check that image and try to think by yourself that what actually the objects it has, and what actually the interrelationship or the contents of that object for virtual environment, the geometrical relationship. Those are things you need to actually explain. Few students have done it, but not all of them. Okay, so those are the concern we had. Now I hope that during the final exam that you will find out which would be done better. And you see that your written exam is not actually the last point that you can actually survive with a good mark. Okay, because there are many scope after having a complete exam, that I can say only the complete exam that you have, whatever the way it is, maybe you are taking help from your friend, you are quickly copying that one, you are sharing the answer and so many things, but still there are many scope that you can get not more than 60%. Okay, so if the question can be arranged like this way, still that can be find out. And so that's why you should actually do some study if you really want to actually cross over the courses. Okay, otherwise it will be difficult. Anyway, so let us actually go with our last discussion about color model that we had. If we if anyone can tell Pratasha how far we have done. We are discussing about RGB model, right?
Yes, sir, we have discussed it.
And did you discuss about the conversion from RGB to CMY?
Yes, sir.
Yes, sir.
Okay, so we have discussed about this one as well, right?
Yes, sir.
Yes, sir.
Okay, that's good. CMYK, why we have an extra K?
Yes, sir, it also discussed.
It's discussed. Then only that HSV model is left, maybe, right?
Yes, sir.
Okay, that's good. All right, quickly just to discuss, whenever we discuss about color model, we said about a model is an abstract mathematical model, okay? The abstract way, or maybe a standard way to identify or to use the color. And we have seen that it has a very important, actually hardware oriented relationship about the color model. One is we are calling additive model, because the light we are understanding as a color, which is actually the additive model, or transmittive model. Okay, or going through, the light is going through in our computer display whenever actually we are watching it. So that's actually the additive model, or from the first one. Another one is subtractive model, which is actually about regarding the printing. Whenever we have the printing page, as you know, that the color we want to see, that has to be reflective. Reflection of the light comes to your eye, then only you can see. So that's why it's called the reflective model. Okay, and this transmitted light and the reflected light, this additive and subtractive, these two of the model. And we have seen that this additive model can be called RGB, the primary colors, and exactly the reverse relationship with CMY, which is actually for the color printing devices. These are the two, mostly the hardware based actually color model that we discussed. And another one is actually the user-oriented color model. This is not directly the hardware-oriented, but it is mostly the user-oriented, the way you actually feel the color, especially on your content. This is also related with the RGB as well, but also can be mapped the CMY, because at one of the model, the primary colors are actually their name, it consists. Whatever the other model is actually having the secondary color of it, we have seen in the color space. That is for RGB color model, especially for computer display. We know that whenever the all colors we have, that is actually the light, and they are actually different wavelength, as you know, that all these colors, and that's created through the transmission of the light. The primary colors for red, green, and blue, whenever they can be mixed up, they can create those secondary colors, which is CMY, we many times mentioned, which is cyan, magenta, and yellow. That is the first letter has been taken. And then in the RGB, it depends up to our vision, actually, that color space. Whenever we are talking, we try to actually explain the space with a three-dimensional cube, and we have seen that this is actually the cube where that x, y, and z coordinate has been defined with the primary values like red, green, and blue. And while their combinations are actually creating that yellow, like red and green is creating yellow, blue and green is creating cyan, and blue and red is creating magenta. When there is no color, that is actually black. Okay, and when we have all color, then actually it is white. That is actually RGB color space. And the same way that we have seen for CMY color model, where it is a subtractive model we have said, and this is for actually printed material that has been said, and this ink especially to display the color, because it will be reflected, and the cyan, magenta, and yellow, all three creating the black. Okay, so that when we check in the space, so that in the cube, that when we have no color, that is actually white. Okay, and when, because nothing will be, light will not be reflected if you don't have any color, and when it is actually the black, means all color it has. And according to x, y, and z coordinate, that actually cyan for x coordinate, magenta is y coordinate, yellow is in actually z coordinate, and their combination is creating the secondary color for CMY is actually red, green, and blue. Okay, on the basis of them, actually we have seen the conversion from one type of model to another type of model. That means if we have in CMY, actually can be defined as equal to 1 minus RGB, because they are actually reverse on their position. So that whenever the red color has been given for RGB, if we want to find out what should be red in CMY, as it is actually secondary color in CMY, definitely will be a combination, so that we can find out like CMY is equal to 1, 1, 1. They are actually the one dimensional vector. Okay, minus RGB, and that RGB, if we put the value for 1, 0, 0, then if we do the subtraction, you get actually 1 minus 0 is 1 minus 1 is actually 0. 1 minus 0 is 1. 1 minus 0 is 1. So that's 0, 1, 1 we get. So it indicates for the CMY model actually, and that's in the y coordinate, magenta and yellow. That magenta and yellow is actually creating the red color. So that we need to go back to the CMY color space and to show that magenta and yellow is creating the red color. Just mark out that one, that this is actually this one. The same way, if we have given something in CMY, like magenta is written in CMY as 0, 1, 0 in CMY, then what it should be in the RGB. So if we can actually put down in the formula like that CMY is equal to 1 minus RGB. So CMY value is for rate. So 0, 1, 0 has been given is equal to 1, 1, 1 minus RGB. So that actually, if we put the RGB in this side and take that CMY in other side, then we get like 1, 1, 1 and 0, 1, 0. So we get 1 minus 0 is 1, 1 minus 1 is 0, and 1 minus 0 is 1. So we get 1, 0, 1 for RGB. So that if we consider that is red, and the blue is combining and creating the magenta in RGB color space. So if we go for that in RGB, for we can see that actually the red and blue is actually creating the magenta in here for RGB color space. That actually we have discussed in the previous class. Also, one discussion was about CMYK. Why that color space CMY has been extension with the extra letter which is K, because CMY especially is actually when they combined all together is actually black. So black color has been defined or maybe dependent on a specific of all three cartes of the color. That's cyan, magenta, and yellow. Now, especially in the printing device, that is, it will be used actually the cartridge as a ink, so that actually we can have a reflection. So that combine not cannot give actually the true black color. So that's why actually an extra cartridge for K, which is actually denoted as K, has been actually added with CMY. So for getting the pure black, actually that's why we need actually an extra one just for advantage for the printing devices, so that an extra that cartridge has been added with that as a black. Okay. All right, we'll go for actually the HSB model. We said this is an user-oriented model, and to understand that model, we have to consider that light is actually not considering as a single wavelength. It is actually blend of or mix of actually different wavelength. These are actually representing different color, and from that concern that we will try to discuss about hue, saturation, and value with some actually visual structure. That what do you understand? But before that, let us go for attendance to finish. Then we are coming back. So please come to the video for a while. And mouse is not working actually. All right. Do you have Alif Laila Jannat?
Yes, sir.
Jannat, Akifur Rahman Ashik.
Yes, sir.
Okay, Ashik, Muhammad Alamin. Muhammad Alamin. Nishat Ara. Nishat Ara. Shahidul Islam Antur.
Present, sir.
Antur. Sumaya Akhtar.
Present, sir.
Sumaya. Arifa Akhtar Ritu.
Present, sir.
Ritu. Jinatul Nisa.
Yes, sir.
Jinat Parvez Alam. Parvez Alam. Redwan Ahmed Ratul.
Yes, sir.
Ratul. Salvi Saba.
Yes, sir.
Okay, Salvi. Chakaria Hassan Papu.
Yes, sir.
Okay, Papu. Maria Mehjabin.
Present, sir.
Okay, Maria. Israt Jarin.
Present, sir.
Okay, Israt. Abdul Khalek.
Yes, sir.
Rabina Afrin Ami.
Yes, sir.
Okay, Ami. Tajnova Yasinesha.
Yes, sir.
Okay, Yasha. Shariar Tayon.
Present, sir.
Okay, Tayan. Hussein Ahmed Antur.
Present, sir.
Okay, Antur. Pratyasha Roy.
Yes, sir.
Okay, Pratyasha. Sharnika Das.
Yes, sir.
Sharnika is there.
Yes, sir.
Yes, sir. She is here.
Is it very low? Maybe I
Yes,
cannot.
sir. Her
Yeah.
voice is very low.
Yes. Uh, Khadija Rahman Ria.
Present, sir.
Okay, Ria. Rahat Islam Rupu.
Present, sir.
Okay, Rupu. Mahmouda Akhtar.
Yes, sir.
Okay, Mahmouda. Didar Al Mahmoud. Didar Al Mahmoud. Tamanna Tabassum.
Yes, sir.
Tamanna Saif Mahmud Sifat.
Present, sir.
Okay, Sifat. Fairuz Tanjim Achal.
Yes, sir.
Achal. Sadiatul Nisa Shetuli.
Yes, sir.
Okay, Shetuli. Mustafa Iram Uday.
Present, sir.
Okay, Uday. Sadia Hussain Mauri.
Yes, sir.
Okay, Mauri. Sadia Akhtar.
Yes, sir.
Okay, Sadia. Mantakimur Rahman.
Yes, sir.
Okay, Mantakimur. Atik Faisal Imon. Atik Faisal Imon. Rahul Devnath.
Yes, sir. Yes, sir.
Yeah, okay, Rahul. Nishat Taslim Jyoti.
Yes, sir.
Jyoti. Sadat Mahmud Khan. Sadat Mahmud Khan. Firdaus Hassan Rifat. Firdaus Hassan Rifat. Minhaj Munib.
Yes, sir.
Nahida Islam.
Yes, sir.
Okay, Nahida.
Yes.
Hasibul Hassan Shanto.
Yes, sir.
Sharmin Sultana. Sharmin Sultana. Ryan Hussein.
Yes, sir.
Ryan Muhammad Alamin.
Yes, sir.
Alamin Tariqul Islam. Muhammad Tariqul Islam.
Yes, sir.
Tariq. And Ashikul Jaman.
Yes, sir.
Okay, Ashik. Okay, that's good. So, anyone left or missed? It's showing 45. So,
Sir, maybe Sharma Sutana has mic problem. Maybe.
is she here in the list?
Yes, sir. She is in the list. Sir.
Okay, so I don't see anyone. Sharmin, are you there? If you have a mic problem, you should write in the chat box. So I don't find her. Where is she? Yes, Sharmin Sultan. Sharmin, can you hear me? She's not aware, maybe. Sharmin, are you there? Okay. All right. Let's back to the content about the HSV color model. That could be discussed actually with a cone shape that will give us a better idea to understand about this model. As you can see that a pyramid like a upside down that if we consider, and it's a hexagonal base, means actually 6 of that line we can create, but it's showing in a actually circle shape, that considering that 6 of that part, and a circle is showing the main reason is a cyclic nature, that's why actually it has been shown. Okay, and this is considering the 3 components like H, S, V, or hue, saturation, and value. okay, can be defined with this structure. Now, if we consider to understand what is actually hue, the first of all, that we use in our remote control also, we try to actually handle that what is actually hue. So it is basically that indicate that the dominant wavelength, okay, especially in your combination of the color, which are actually looks dominant, that actually create the type of the color. Okay, so I may say like, okay, it's a red type of color or a green type of color or blue type of color, that actually I can tell that. Especially you can have actually the other one as well. Other one means actually the cyan, magenta, yellow, or maybe the secondary combination of other color. But and this example we are actually trying to show that you can see here that the hints of those three colors. Actually, you have other colors as well in here, like yellow. You have the magenta and also the cyan as well. But the reddish, the bluish, or maybe the greenish, these are actually color. Now, can you see any significance here with this the diagram that you can see? Anything which is significant? Ashik?
Sir, does red comes twice?
And red comes twice. Actually, you can see the other color is not repeated, but red comes twice. Yes, that is the significant part. That means this is actually a cyclic nature. So that hue, you are having the highest value, highest value and the lowest value. In the both cases, you got actually the rate, right? That means it's coming back again. Okay, so that's why we have a actually that cyclic nature. As you can see, that it's coming back again. So this is 0, and when it is coming back in the highest point in here, 1, that is also red. So it can happen for any color. Okay, so that actually give you the type of the color with their actually the dominant wavelength. So the hue, actually it says that the type of the color, the dominant wavelength, and determines the type of the color, for example. So whenever it is considered about hue, you just remember that this is telling about the type of the color. Okay, the HSP spectrum of bright pure colors, that what actually we can consider, the saturation value is high, the value or that is actually also high, the V, that is the value is related with the brightness. So that is when it is high, that is actually we can say the bright pure color that we can see. The cyclic nature of the hue that we have already seen, the red corresponds both to H is 0 and for H is equal to 1. So in the both of the cases, that red is coming, that means for the cyclic of that nature. Okay, so this is actually called the hue that you need to remember, that is talking about type of the color. The saturation, the saturation determines the purity of the color. Now, the previous hue said type of the color, saturation is actually purity of the color. Now, how actually they have been defined? If we go back again with that cylinder, that we can find this cyclic nature in that circle, that shape is actually considering the hue. Okay, so the value for high to low, okay, that gives you actually the same that color of that point. Okay, but it has actually that primary color in the hue, that red, green and blue. You can see that red and green is creating the yellow, as you know, in the secondary color in the RGB space. Or the same concern we can have like yellow, if we start with yellow, and cyan may create the green. Okay, so the same way they have a relationship. So red, green and blue, then the yellow, green and red is creating yellow, green and blue is creating cyan, and blue and red is creating magenta. Okay, and that center point is actually white. Now, so that in y coordinate, that if we consider, this is actually at two of the extreme point is having actually the white and the black. Okay, so now the V is actually considering, or that value is considering that white and one point for that actually it's black. So two endpoints if we consider. That means actually the value here, when you have actually the highest value, that is actually this point. When you have the lowest value, then this is actually this point. Now what is the saturation? Saturation is actually the x coordinate. That means actually from that center point, when you go actually further away in the x coordinate, so that would be the highest value, and when you are in the center, that is actually your lowest value. That is actually the saturation. Now this cycle in the circle, actually it's giving you the type of the color, as you can see. Now this is actually the x coordinate giving you the purity of the color. Why we are talking about purity? Think about any point which is getting close to the center. That means it's getting close to the center is white. Okay, then it is getting what? It is actually losing its purity. A color is combined with many number of white is actually getting what? Like this one, right? As you can see, whenever we can say a pure color, that means you need to see actually the color is quite bright and they can be identified. Okay, now when you have actually high saturation, okay, that means it gives the pure color with narrow wavelength band. So whenever you are going in that circle from that point, okay, from that point to you are going in that one point, so it is giving the narrow wavelength. Why it is narrow? Because that specific yellow color of wavelength is actually that time will be found. If you go in there, which is the specific wavelength for green, that will be found, or maybe that is for the cyan. So from the center, when you go as to the circle that circumference on that boundary, as much as you move, the wavelength will be the narrower one, or that means the finer one that you go, and so that you can see the color, the pure color for that. Okay, but as long as you are coming to the center, will be mixed with the white, and whenever you will be mixed with the white, then actually your purity will be lost. Okay, so you will look like a lot of white with that. So while low saturation means that the color mixed with a lot of white light combines all the visible wavelengths. Okay, so that wavelengths are actually mixed up then, and then actually you will lose the purity. You can see that it's not very clear of the color that you can actually identify. So this is actually showing the bright colors. That means V, the value, the Y coordinate is highest. That means with decreasing value of saturation, your brightness is high, no problem. That means in here, your brightness is high, which is actually we are considering that one. So when you go down, that is you are losing your V value. That means actually the brightness is going low. Now this image for this one is for saturation is showing when your V value is 1. Okay, and this saturation is actually this point, it is actually 1. That means in the boundary. Okay, and that means the type of the color also can be identified. If you are in one point, then you are actually coming to the center. Okay, you are moving towards the center, so your saturation now become only 0.25. Then actually lots of white you can see, and when your saturation value is 0, then actually you can see only what? When your saturation value is 0,
It's white.
it completely white, right? That means you are in the center. Now our one condition we had, when our value is 1, that means actually this point we are in here. Now if we consider what is value, value is actually determines the brightness. As you can see in the diagram, that when the value has been decreased going to in there, that means going to the down. Okay, a value is equal to 0 represent that absence of light, there is no light, while a high value gives the bright colors, which is actually on the top on the circle that if we reach. So pure color, that means the saturation is actually pure colors with the saturation is high, with decreasing value of values of value, the brightness that is actually showing in here. This is actually showing when you have pure color. The pure color, that means your saturation is high. So whatever you are in the boundary. Okay. Now, and you are actually decreasing the value, that means the brightness, so that actually you are going more like in the black part. So what actually your image is going to be is getting blacker. Okay. So at only 0.25%, so that's why it's still something you can see. But when you are on the actually value is actually high, then you are actually going down, 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 and this one. Now this is actually that HSV model. Okay. So the first one, when we consider that hue, our saturation was 1 and the value was 1, then actually we can see a, a dominant wavelength, or we can say the type of the color that actually we can see. Okay. So any type of the color, to see that one, you must have to be anywhere in that actually boundary. Okay. So that if I say like I'm in here to show the magenta for at this point, your saturation is actually 1 and also your value is 1. If we anything is loose, like saturation loose, means you are going more like in the center point. Okay. And it's mixing with white. But if your saturation goes down, also actually your value goes down, that means it is started to get dark. Okay. So that you cannot see for the saturation that has been actually considered. So you may identify your position according to the value of those three. Like if I say like, okay, your saturation is your hue is actually say like zero point 0.5, maybe you were in here. Okay. If this is say like 0 to 1, so if it is 0.5 in here, and then actually you consider that your saturation is say like zero point 0.5 as well, so that you are in the middle in there, but your value is also 0.5, so that maybe you are in here. So whatever you can see, that the image is would be a little bit darker. Okay. And also you can see some mix of the colors for that. It should not be the pure color if you don't have the saturation is actually that 1. So to see any pure color, any type of the color that if we consider out of the 6, just for considering any type of the color with actually the saturation is 1 and the value is 1, then actually we can see the best one. Okay. And the black and white depends on actually the brightness that we have said about the V. Okay. So this is actually the HSV model. You do find it in your remote control as well with your television. You can check at your home that how the image is changing with the 3 of this value, like brightness, hue, and saturation, that how it can be changed. Right. So do you have any question about it? Do you understand about the HSV model?
Yes, sir.
Yes. Anyone have any
Yes, sir.
question? Right. So you can see this is also actually a model to explain that what actually the relationship, they are interrelated, because whenever you have any position in the space, so definitely it has some value according to this 3 dimension that you are considering. 3 dimension, I'm actually talking about not that dimension. The dimension is actually hue, saturation, value. The 3 element, it has an interrelationship with that. Okay. HS, many places it has been actually said also HSI, that I is again the brightness or intensity or value, or HSB as well. Sometimes it says hue, saturation, and brightness. That HSI, the intensity, also the same with the value as it is. Okay. So this is also important, HSB. The 3 of this model that we have discussed, RGB for actually the transmitted light or additive that color model. We discussed about CMY, which is actually the reflective color model or subtractive color model. Both are related with the printing devices. This is this one, while the additive one was for the display, and HSB is actually for both of them, indicating the user oriented this color model. User oriented, why it is talking about, because it is about your perception of light at different wavelengths that actually you are considering, what actually you can see in huge saturation and value or intensity of an image quality. That is, you can change, as you can see, with these three of the elements, hue, saturation and intensity. Okay, so that's all about this color model. I just quickly point out, I hope that you just point out this one, okay, for your further reference when you are going for preparation for your exam. This chapter we basically discuss to understand about the relationship about that color, that display. Okay, that color has been displayed, what we call that video color map lookup table, that organization for it, that how actually the interrelationship we have. This is important, that one of the pixel has been given some address with some color value, how it can be represented. That is in a simple to say. So in the bitmap with that lookup table for that the pixel, the value can be converted to the binary format, which will give that positional, that red, green and blue, one after another as the order that the bit will be actually distributed, and according to that the intensity will define. Okay, that's actually color map lookup table is important. Then the conversion between these two model can be important for having some question. You need to again I'm saying, whenever maybe in the question it will be identified, or it will be said like identify the color into the, or explain the color in the color space as well. So this question, whenever it is given to CMY and you are asked to find out that in RGB, then you have to draw actually the RGB color space to show that color. Okay, if the question says that the CMY has been RGB has been given, you need to find out in the CMY, then you have to draw actually a CMY color space to show that one. Okay, so this conversion, and finally that the HSB model, that is actually the thing that you can take preparation for it. Okay. Okay, now we go back for a very important chapter, which is called the transformation. Now, can anyone tell me that what do you understand about the word transformation or transformer,
Change on to another.
change one to another? Yes, very good. The changes are actually obvious in our image, right? So far we have discussed about, or even in your flag assignment you have done actually what, one of the shape. That shape has been consist of actually multiple number of primary shape, and they have maybe created a shape as a whole in a single object that we are actually thinking. Now, if we have that, okay, it is a flag, then actually it is maybe have a movement. Okay, if we have a movement of that flag, definitely the position in the that flag in the space will be changed, right? If we have a movement, then actually it can have a movement for the image objects inside the objects. Actually we have seen that geometry, then we have also seen that there's an interrelationship between the objects. We discussed about the sun, the position of the building of IBAT, the position of the cancer hospital, the shadow are actually having some kind of interrelationship content which is having changed according to the position of the sun. Now, the transformation is especially important. That's why, because it is actually giving you the idea about the movement of the objects. Okay, that means we call it animation in another word. That animation comes from the movement of the animal, because the object which is actually having movement, those are especially in the species of the animals, as we know, have a movement by our own, but the other object is not. So that movement can be done, primarily to think can be done is by two ways, because end of the day, as you know, that this is actually all of our visual perception. A blind man, a person cannot see, actually it does not make any sense of the image to him, right? Because he cannot see. Now that from that concern, if you can see, on the basis of that, actually you can feel the object is having a movement. Now you see, then the old movies, there actually we have seen some, say like in romantic movies, that the hero, the main actor, and the actress both are actually riding in a car. As we know, the man is actually driving the car. Now in the old movies, as you can see, that not always that car need to be actually driven, so that actually the cameraman has to take it, rather than sometimes they are sitting in a static car and having some movement, and somehow maybe the background is actually moving. So someone is actually moving the background. So from one point you are feeling that maybe the car is actually moving, right? Have you seen that?
Yes, sir.
Yes, sir.
Yes. You also have seen in the cartoon as well, right? The old cartoon as well, that some, whenever is some object is actually running, say like that, in the background is actually, it's been going behind, and when it is going behind, maybe in a loop, if you that put that going behind and that object is only one place, have some movement, you will feel like it is actually moving forward. So that's why I said, like, everything is actually kind of an illusion to your brain. Okay. So if you can create the illusion, you will feel that is actually the truth. Okay. Now these changes can be done in two ways. One is called the geometric transformation, one is called the coordinate transformation. Now this geometric transformation is when really the object is actually moving. That means the actor is really actually driving the car. And the coordinate transformation is actually when that background has been actually movement. That is actually the coordinate transformation. So for let me try to draw. I'm not sure that whether I can do it, because my mouse is giving so trouble. It's not working mostly. So that if we have a screen and we have a object, say like we have an object there. Now, if I want to move that object in this one, so what we can do in my diagram, sorry, so that, okay. So that what we can do the object moved in this place by changing their position, right? So entire space has some coordinate values according to x and y. So this object having some specific coordinate value in here. So if I change that coordinate value, the object should be moved, will be moved in here, right? So I can actually move that one. So the object can be moved in here by changing the coordinate value. Another thing what we can do actually that in the space, the object we had in here, okay, we will move the entire coordinate. So the object is static, okay, but the coordinate we have changed. What actually I meant, the object is in a static position, but I actually moved the coordinate. So the object becomes now coming in that corner, right? So the two way we can do the moving the object one way, or another way is actually the coordinate itself, that is actually we are moving. So that actually from here to we can find that the object has actually moved in there. That has been actually done with cartoons or maybe those old movies, that you are changing the coordinate of the backdrop, okay, so that you are feeling that the object is having a movement. So that if we go back to the slide, the same thing has been said in our geometric and coordinate transformation. If we think about the geometric transformation, we have seen that the first is the object itself is moved relative to the stationary coordinate system, stationary as it is static, that's why, or background. The mathematical statement of this viewpoint is described by its geometric transformation. We'll do it this geometric transformation, and coordinate transformation is actually when we see that the object is held stationary, so it is not changing, rather than the coordinate system is moved relative to the object. Okay, and this effect is attained through the application of the coordinate transformation. Little bit complex activity, because when you go for actually the background movement, an example involves the motion of an automobile against a scenic background. That if you have a scenery in the background, we can keep the automobile moving while the backdrop is fixed. So it is not changing, the car is actually moving. So that is geometric transformation. Or we can keep the car actually fixed and moving the backdrop scenery, which is called the coordinate transformation. In some situation, you may apply the both actually method, and this is actually called the transformation into type. Okay, so very important concept for computer graphics, because as you know that this transformation are actually fundamental part, as you can see, the primary part, because you understand the image so far with the object and so everything. Now the movement of the object is actually your concern. Now, what actually this what is called this transformation can give us? We are basically discussing 2D transformation. The depth we are not considering at this moment. This is actually related with the two-dimensional, that the height and length in the x and y coordinate, especially we are considering at this moment. So an object is actually nothing but it consists of many number of vertices on the space. We all know already, so that you can define with many number of points of that. So if it is a set of points, if we want to have a point coordinate, say like an individual point is coordinate x and y, and the object is actually considering is a set of group of that. And when a object is moved, that means that point has been moved from P to P prime, a new object, say like it. So entire all these points relevant of that should be actually moved. Okay, so that we are talking about a box. If we have, so one of the point of that box has been moved, means relevant all the points of that box also will be moved. Okay, that's in the geometric transformation. Basically 3 types of transformation we are going to discuss are, which is actually relevant, and the other one we are not actually emphasizing, that one which is called the mirror reflection, especially in the coordinate basis. The main 3 of them are actually the translation, scaling and rotation. Okay, as you know that these 3 of the thing, the possible thing, are actually common in the images that we can actually consider. Now, what is translation, what is scaling, and what is actually rotation? If we go for drawing, let me try again for drawing. For considering that translation, as you know that what actually can happen, the possible changes on the images of an object can be, say like, I have a space where an object, I have a triangle. Okay, so whenever we are talking about translation, what are the changes can be? The triangle can move in any of the space, like it can be in here, it can be in here, it can be in anywhere, any random places that it can be. Now every time it is actually moving, it is moving its coordinates values, right? And the changes is actually relevant only that its coordinate values has been done. This is one type of changes, that the movement, or one type of transformation. This is called the translation. Okay, so that translating from one point to another point. It can happen another way of the changes. Sorry, the boundary has gone. What actually the way of changes? Say like this is that object. Say like 3 point we are considering A, B, and say like C. Now we found that object is like that, where this is actually now A, this is actually the B, and this is actually the C. The difference is the object has been rotated, right? You see that A was on the up, it goes in the down. So it is almost rotated in maybe some degree, right?
Yes, sir.
So that's actually the rotation. So on basis of some degree, definitely whenever we talk about rotation, rotation means is some degree of the movement, and some degree of that movement can be done only centering one of the point. Then only you can count actually the rotation, right? So that's on the basis of that, that is actually called the pivot point or pivot point, whatever the way you pronounce. On the basis of that, actually it has a rotation. So this object it is actually rotated on that actually way. So this is called the rotation, another type of changes. Then we can think about another type of changes. Say like it can be look like that, or maybe it can be look like that. What actually the changes happen? The sizes, right? That is actually called the scaling. This one actually increased the size, so maybe I applied some time of the scaling factor, okay, some factor of say like twice time it gives. So now like this one maybe thrice time it has been actually expanded, right? But this one is maybe decreased, getting smaller. Maybe I said, okay, half of the size that it should be, so that it become half, or maybe 3 times smaller, so that it becomes actually 3 times smaller. So this is also change. Why we are talking about change? Change is actually say like it's all the points that actually you have defined, that all the points position, they are actually changed when in the space when you have a size. So you don't have change in there, but you said okay, increase that one. When you increase that one in the same position, again the A, B, C point has been changed their position, right? So that is also actually a transformation. So whenever we talked about that rotation as well, if you do not change in the different position, if you don't go, it still actually it happen what, that your rotation, according to your rotation, so that you in the same point you have actually rotated like that. So again that A, B, C, so A, B and C has been changed. The point it was, it has been now have a change in the space. Okay, so this is actually the basic idea. I think the time is up. You also have a class, I also have a class. So that next class we are going to discuss in detail about the tree of that function. We'll try to see that how in the geometrical way that can be handled. Also actually we'll try to go through with the sub problem solving of that. Okay, that is important for your exam. All right, okay, take care. I'll see you in the next day. And any of the extra class, again I said, like if you have extra session rather than the class, that it will be informed very short time. Okay.
All right, sir.
Okay, take care.
Okay, sir. Assalamu alaikum.
Assalam.
Assalamualaikum.
Assalam.